Okay, we're in section 13 now, which is the section on the zero product rule. We reviewed the lecture with you. I want to point out this is related to factoring. However, we're using factoring to solve equations now. The prior questions were not equations. They were just expressions that we factored. Now we're going to be given an equation and we're asked to use the zero product rule. We're hoping you spend some time thinking about what was presented though. And by thinking about it, you want to start to apply this method. The method says if we have a product and that product equals zero, then the factors of that product must also be equal to zero. So what we did, we went through some examples already. Now we're going to go to the formal examples and work through those. All right. So we switch to the whiteboard. Just give you a second here to get this working. Okay. We're sharing the whiteboard with you now. We're sharing the examples from section 13. So I'm certainly going to work one example at a time. And by that, what I mean is I'm going to look at this. And I just want to remind you, we're going to use zero product rule. Let me just pull a problem to the side. And I'm going to do that. I'll try to do that anyway. I take this problem here. I'm going to pull on the side. All right. Okay. Now, certainly you can put a wrong answer down quickly. I'm not opposed to that. You should be opposed to that because you want to get credit, move out of this course and move on with your academic careers. So I'm looking at the problem. I want to point out this section here it has to do with what's called the zero product rule. So zero product rule. So I'm going to say every question should look like this, that it should be zero and a product. I have a product, but I don't have a zero. So that's a trouble for me. So once I get in the form though, it's really easy to write an answer down. Let's just say A is zero or B is zero. Right. So my claim over here is that this equation you're giving me is not in the proper form. So my first step would be just to simplify it. Would you get y squared minus 3y plus 2y minus 6 equals 14. Well, this would give you y squared minus y minus 6 equals 14. What would I do now? I'm going to subtract 14 from both sides. And what would you get? You would get y squared, right? Minus y, and minus 6 minus 14 is minus 20. And that equals 0 now. So now I want to point out what I have. At least I have a 0, all right? So I have the 0. I have that part. What I don't have, though, is I don't have the product. So my goal here, and hopefully it's going to be easy to do, is to get a product now. So I'm looking at this, and what does it mean to get a product? It means I'm really going back to prior sections, and I'm going to factor this guy. So y times y, if it's to work, is the only choice I could have. But now 20, what would you do? Well, again, the hope is you're getting a little better at factoring. I'm going to say 4 and 5, but I want to emphasize this. No matter what I say, I'm going to check it. I'm going to say minus 5 plus 4. Well, if you check it out, y times y is y squared, worked beautifully. Then you get 4 minus 5, which is minus 1y. That worked beautifully. And you do get minus 20. All right, what I'm going to do now, I'm going to use the rule, which says if I have a product equals 0, just take the factors. Whoops, sorry about that. Just take the factors and set them equal to 0. I'll do that for you right now. So the factors are going to be y minus 5 is 0, or y plus 4 is equal to 0. And what do I get up here? Y is 5, or y is minus 4. I'm going to say that's my answer. Of course, you could check it with the k. I want to point out what that means. You look at the k, and you should see these answers. Now, if you're on the exam, you don't have a k. So what you're going to do is check it. And someone says, where would you check it? You're always going to check it in the original. So I'm going to check it now in the original. I'm going to check y equals 5 first. I want to see if it works out. Now, if y is 5, the first factor would become 7. And the second factor, 5 minus 3 is 2. Is 7 times 2 14? It is. That checked beautifully. Now I'm going to check y equals minus 4. And what would you get? Well, in the first factor, I would get minus 4 plus 2, which is minus 2. And the second factor, I get minus 4 minus 3, which is minus 7. Does that equal 14? Of course it does. All right, let's go to the next question. All right, next question. Question number 2. And again, I realize this seems repetitious to some students, but you really do want to repeat over and over again the concepts that we're trying to get across to you. All right, so I don't know, let me just push this over a little tiny bit over here. We'll come back to that later. All right, so what I'm going to do over here, and again, I can't say it times, it's going to be 0 product rule. Well, I got to get 0 first. So I'm looking at it. What do I say? I see a squared plus a. To get a 0, I would subtract 6 from both sides. So I have the 0 part. I don't have the product though. I'm going to write that down for you. A and A. I'm factoring. It would be absolutely awful to give you problems you can't factor at this point. But I think I can do it. 3 and 2. I'm going to say plus 3 minus 2. No matter what I say, though, I'm going to check it. What's a times a is a squared. Plus 3 minus 2 is 1a. That worked beautifully. And you do get minus 6. Then what do we do? Well, we're going to take the factors and set them equal to 0. So a minus 2 equals 0, or a plus 3 equals 0. Now, I'm going to claim that you don't need to write that down, but the reason I write down is I want to make sure you know where these numbers are coming from. So for example, in the first equation is a minus 2 equals 0. What does that mean? A equals 2. Or the second equation would be a equals minus 3. Now, when you're doing homework, you'll notice that these answers are clearly listed over here. If you're on the exam, though, no such luxury. You're going to check it. We'll put this down, check. What am I going to check first? Probably a equals 2 because I thought it easy. Where do you check it? In the original. You always do it in the original. Well, what's a squared? 4 plus a, which is 2. Does that equal 6? Of course it does. I'm also going to check a equals minus 3. And what do you get? Minus 3 squared is 9. Plus minus a is really just minus 3. Does that equal 6? Of course it does. Works out beautifully. All right, let's go to the next question. And I got to move this around a little bit. And give me a second. Push this on the side here. Oops. And let me just get rid of this thing over here. I push this over here. All right. So we're going to do number 3 now, right? I think I know what to do. I think I'm getting better at it too. And so what are you going to do over here? Again, some students, they certainly understand what I keep saying over and over again, 0 product rule. I want to tell you, what would be a mistake for a large number of students is to subtract x squared from both sides. I want to write that down, but I want to claim it's a mistake for most students. I'm going to erase this though. And I'll tell you why it's a mistake. Most students have a difficult time if there's a negative coefficient on the leading term. So what I want to do is I want to keep the x squared on the left side. So I'm going to erase this over here. But again, you might say stuff, I still want to try that. I'm not saying you can't try it. I'm just knowing from experience. I just know from experience that students have a tough time with that. So what I want to do is subtract 2x from both sides. I'll write this down for you. And I want to subtract 35 from both sides. I want to point out what I did. I'm subtracting 2x from both sides. And I'm subtracting 35 from both sides. What would you get? X squared minus 2x minus 35. All right, let's go to town. I'm factoring it now. So I'm going to say, basically it looks pretty simple. Again, I have my 0. I'm looking for a product now. I'm going to say 7 and 5. Again, just by trying prior homework assignments, I'm getting better at this. Let's just check it though. I always say I'm better, but who knows, maybe I'm wrong. X times x is x squared. This could be 5x minus 7x minus 2x, and you do get minus 35. What am I going to do now? Set the factors equal to 0. Now, some students are going to say, I can do this without writing it down. I'm not opposed to that. What do you get over here? X equals 7 or x equals minus 5. Let me put what I mean by that. Some students look at this and say, oh, X must be 7, but they don't write this down. That's fine by me. Some students look at this and say, oh, X must be -5, but they don't need to write this down. All right, that's fine with me. So what I want to do is put a box on it, get my little red ink out, and see if I did a good job. I see -5, I see 7. I want to check it though. The way I'm going to do that, I'm just going to look at this and I'm going to plug it back into the original. So if X is 7, what would you get? 49. And 2 times 7 is 14. Well, 14 plus 35 is 49. That worked beautifully. Let's try this one, which is -5. Again, I'm checking it here. What do you get? 25 equals, well, 2 times -5 is -10 plus 35. Does that check? Beautifully. All right, let's go to the next one. And this is number 4 now. All right. Again, I'm going to encourage you to keep the square term with a positive coefficient. So what I'm going to do is, subtract 15s from both sides. I use a cursive letter S. The reason being is if I write down the print letter S, it might start looking like a number 5. And that's too dangerous for me to do. Erase it over there. Again, you do not need to use a cursive S. So minus 15s, and I would add 56 to both sides. You should be getting somewhat better with equations. Again, I'm subtracting 15s from both sides, and I'm adding 56 to both sides. And what would you get? S squared minus 15s plus 56. What I'm going to do now, factor it. And again, it would be awful to give you things that you couldn't factor. It would be really awful. I'm looking at 56, and I get a better idea what's going on because it's just from practice. And that's really so true that when you start to practice, you get a better idea. And this is a very simple game we're playing. And I'm going to say 8 and 7. And why is that? 8 times 7 is 56. Now I'm going to put minus down. I'm still going to check it. I would never say this right until I check it. S times S, S squared, beautiful. Minus 8, minus 7 is minus 15. That's beautiful. And what do I get over here? Plus 56. Now what do I do? Well, I'm thinking it maybe I could actually write the answer down without writing down, the intermediate step. But here's the deal. I want to write the answer down, but I still want to write the step down for those students that need it. So what's the first factor? The first factor is S minus 7. When does that become 0? When S equals 7. Or the second factor is S minus 8. When does that become 0? When S equals 8. Again, you may need to do this. S minus 7 equals 0, or S minus 8 equals 0. And if you need to do that, do it. That's simple. So I think that's the answer. I want to check out my answer key. Whoops, let's get the red ink out. 7 and 8. Looks good. I also want to check it. Where do I check it? In the original. Let's put this down. If I check 7, what do you get? You get 49. And let's see, 15 times 7, that's going to be, well, let's see. That would be 70 and 35, 105. Minus 56. Let's see, 49. This worked out beautifully. All right, let's try the other one. Again, you need to be able to do arithmetic, of course. 8 squared is 64. Equals, well, what's 15 times 8? That would be 80 and 40, 120. Minus 56. Well, it's 44, 54, 64. That worked too. All right. Let's go to the next page. And I'll look at it. And we're going to do one problem at a time. I'm getting a little bit better at this, by the way. A little better. Let's take a look. So what would I do there? I would subtract 56 from both sides. And what do you get? And these should be relatively simple questions, by the way. So you're going to get, let's see, you're going to get 4x squared plus 20x, and I subtract 56 from both sides, and that equals 0. Now I'm looking to factor it, and I'm looking for that GCF, and I'm going to say 4 times x squared plus 5x minus 14. All right, make sure that's true. You get 4x squared, 4 times 5 is 20x, and 4 times 14 would be 40 and 16, 56. I'm still going to try to factor it. And what do you get? X and X. I want to again emphasize this is equal to zero, zero product rule. And I'm thinking 7 and 2. Plus 7 minus 2. Let's just check it. X times X is X squared. 7X minus 2X is 5X. And that would give you minus 14. Looks like it's working pretty good. So write the answers down now. X equals 2 or X equals minus 7. And by the way, if you want, you can write down X minus 2 is 0 or X plus 7 is 0. All right. We'll check it in the key later. Some people say, what about this 4? This 4 is never equal to 0. All right. But X minus 2 is equal to 0 when X is 2. And X plus 7 is equal to 0 when X is minus 7. I'm going to go through the check. What do? I look at my key and I make sure I feel good about that. And I do. I'm going to check it with the original though. Now, granted, someone says, do you really need to do that? No, but it's nice to know you're right. Not just because you agree with me, but that you know you're right. What do you get? Well, 4x squared, if X is 2, that would be 16. And 2 times 20 is 40. That certainly equals 56. They said it would. Let's try this one. A little more difficult. Minus 7 squared is 49. Right? I'll write that down for you. Minus 140. I realize I'm writing over my little TV though. We'll clean it up in a second. What's 4 times 49? Well, I would actually say 4 times 50. 4 times 50 is 200 and take away 4. 196 minus 140. And let's see what you get there. Wow, you get 56 again. Works out beautifully. All right, let's do the next one. And that'll be number 6, okay? So let's take a look at number 6. And I'm looking at it, and certainly I want to write this down. It's 2z squared minus z. I would subtract 3 from both sides. I got my 0. Now I'm going to look for a product. Oh boy, I made a mistake there, didn't I? So I put an x down because I'm so used to using x's, but it's actually z. So 2z and z is the only way to get 2z squared. How could you get the 3? Well, I got to look at it. It could be 3 and 1. That's about all the choice I have. Question is, where do I put them? Well, let's try this. Again, if this doesn't work, I will try again until I get it. What do you get over here? 2z times z, 2z squared. This is almost always guaranteed in trial and error. 2z minus 3z is minus 1z. That worked, and you do get the minus 3. So let's write this down now. What am I going to write down? 2z minus 1, I'm sorry. I didn't copy what I said. 2z minus 3 equals 0, or z plus 1 equals 0. Now again, some people say, I don't need to write that down. Then don't write that down. You don't have to write that down, right? But I'm going to say these are pretty simple equations to solve. For example, z plus 1 becomes 0 when z equals minus 1. The other one, a little more complicated. It's 2z equals 3. And then you would divide both sides by 2, and you would get 3 over 2. I put a box in this, and I want to check it. I want to see if I have z equals minus 1. I do. And 3 has, and I do. I still want to check it. And for some reason, it's just crazy to check this. I don't want to check anything. I just got to trust myself. I still want to check it. And I'll check one at a time. Now, which one of these two answers is easy to check? I'd say minus 1 is. Where do you check it? In the original. What are you given? That would give you 2. Minus a minus 1 is plus 1. And that certainly equals 3. That's done. Let's do the other one. More difficult. What do you get? 2. And then, 3/2 squared would be 9 quarters minus 3/2. And they say that's equal to 3. Well, let's see if that's true. If it's not, I have to say this is incorrect. So you can get 9/2 minus 3/2 is 3. What's 9/2 minus 3/2? 6/2. What's 6/2? It's 3. Certainly makes sense. Okay, it makes sense. All right, let's go to number 7. And I'm going to pull it on the side because I realize that some of these problems might take a little more effort than I expected. Whoops, didn't mean to do that. Let me just push this over here now. And I'm going to try to do it. All right. Okay. I realize let's look and say, you cannot deal with these numbers. It's not going to work. We would never do that to you. You have to understand that the questions we give you, you can do them. Now, granted, as time goes on, you may be confronted by questions you believe you can't do, but not here. All right. You'll be able to do this problem if you try. Let's write this down. So I'm going to say it's already 0, but I don't know the product. There's no GCF. So I'm going to look at it and I'm going to make a stab at it. It could be 8 and 1, 2 and 4. I'm going to try 8 and 1. I'm not saying it works, by the way. If it doesn't work, you know what? At least I tried. And you have 3 tries to get it. What's 8v times v? 8v squared. And now I'm going to try 4 and 1. And so it says, why are you thinking of those numbers and the other numbers? I'm actually looking at 33. And I think I see it because 8 times 4 is 32 and then 1v. So I think this is going to go. But I would never say it works until I try. Let's try it. What's 8v times v? 8v squared. Then you get 32 v's plus 1v, which is 33 v's. What's 1 times 4? 4. It worked beautifully. Let me write this down for you. 8v plus 1 equals 0, or v plus 4 is equal to 0. Well, 8v would be minus 1. V would be minus 4. All right, we'll check these later. And I'm looking at it. If 8v equals minus 1, v would equal minus 1/8. Or, well, v equals minus 4. Okay, put a box on it. I want to claim that in the answer key, you'll see those answers as well. But I still want to check it. Where do I check it? In the original. I know it's frustrating. You're not obligated to check anything. All right. So I want to check it. I'm going to check the minus 4 first. What would you get? 8 times 16. Now, next thing I see is minus. And why is that? Minus 4 times 33. Well, 4 times 30 is 120. Got another 12, 132. Well, let's see. What's 8 times 16? That's 80 and 48. 128 minus 132 plus 4. Let's see. 128 minus 132 is minus 4. And minus 4 plus 4 is 0. That worked beautifully. Let's try this one. Again, somebody said you're wasting time checking. Not really. I'm proving my arithmetic skills by doing this. And what do you get there? 8 times 1/64 minus 33/8 plus 4 equals 0. Well, a little complicated. This should be 1/8 because the 8's cancel, minus 33/8 plus 4 equals 0. Now, if you combine these two together, what do you get? Minus 32/8. I'll write that down for you. Plus 4. What's minus 32/8? Minus 4. Certainly equals 0. Everything's working out fine, as advertised, by the way. We tell you these things are going to work. They're really going to work. All right, that was number 8. And I think I'll go to the next page now. All right, we just did number 8, right? Did I do 8? Oh, I'm sorry. That was 7. Now I have to do 8. All right, this is number 8. Sorry about that. Well, I'm going to do it for you. And what do you get over here? 24 z squared minus 24z minus 18 equals 0. What happens to a lot of students is they try to factor, but they go out of order. And the first thing in factorization, look for a GCF. And is there a GCF? Let's see. I'm going to say 6 is common to all 3 of those terms. You get 6 times 4z squared minus 4z minus 3. Now, someone says, why do you do that? It actually made the problem easier for me now because the choices have been reduced greatly. For example, before I had 24, now I have 4, and 4 is far fewer factors. Let's take a look at that. I'm going to say 2z and 2z. By the way, I'm not claiming it works. I'm just claiming I'm willing to try that. And then 3 and 1. I'm going to put this over here. By the way, I'm not saying it works. I'm saying I'm going to try it. 2z times 2z, 4z squared. This is always working in trial and error, by the way. It's the middle guy I worry about. So 2z times 2z, 4z squared. Minus 6z plus 2z is minus 4z. That worked beautifully. And you do get minus 3. All right, what am I going to do now? Set those factors equal to 0. Now, some students like to set 6 equal to 0. 6 is never 0, but 2z plus 1 is equal to 0. And what's the other factor that could be 0? 2z minus 3 is equal to 0. Let's solve this. What do you get? 2z minus 1, or z equals minus 1/2. Or, well, this is going to be 2z equals 3, or z equals 3/2. All right, let's look at the key, see if we got the right answers. And I'm seeing it. By the way, I do want to check it. And I realize it's very frustrating for some students, particularly if you're weak with arithmetic. All right, now I'm going to say minus 1/2 looks pretty easy to check. So what do you get? 24 minus 1/2 squared is 1/4. This would be, well, let's see, minus 24 times minus 1/2 would be plus 12. And they say that's equal to 18. I got a little more arithmetic to do. What do you get over there? Well, 4 goes into 24 6 times, and 6 plus 12 certainly equals 18. So that works good. Let's try the 3s. More difficult, though, no doubt about it. So let's just check it out. What do you get? 24. And what's 3/2 squared? It's 9/4. Minus, well, it's going to be more difficult. I'll write it down for you. 24 times 3/2. And we'll go through it in steps. All right, 4 goes into 4 once, goes into 24 6 times. 6 times 9 is 54. Minus, let's do the next one. 2 goes into 2 once, and it goes into 24 12 times. And 12 times 3 is 36. And what do you get there? 18. 18 does equal 18. Works beautifully. Now, someone says, why can't we just trust your key? You can. I think you can trust my key. Do I make mistakes sometimes? Of course I do. Here's the deal, though. When you get to an exam, you know, what key? You have no key. You're just trusting yourself. And I would say verify, verify, verify if you can. All right. That was number 8. Let's go to number 9. And number 9 says you couldn't possibly do this. We don't give you questions you can't do. It will be awful. It really would. So what I'm going to claim is I got to get a 0 and a product. Let's write this down step by step. So b squared plus 8b minus 15. On the right side, I would get 2b squared. And let's see, you get minus 10 plus 3 is minus 7b. Again, 2b times minus 5 is minus 10, and 3 would be minus 7b, minus 15. Now what I'm going to do, I'm going to subtract b squared from both sides. I'm going to subtract 8b from both sides, and I'm going to add 15 to both sides. Now, I want to assure you that the problems we write are going to work out really nicely. If things are not working out nicely for you, then you're probably doing something wrong. All right, what do you get here? B squared minus 15b. 0 equals, I need a product, I'll factor the b out, and you get b minus 15. All right, we've been doing a lot of problems. I think I'm ready to do this. And the first factor is b. When does that equal 0? When b is 0. Or when does b minus 15 equal 0? When b is equal to 15. Let's get a red pen out and see if we did a good job. B is 0, B is 15. If you like, you can check these. I'll check this one first. If you plug in 0 on the left side, you get minus 15. If you plug 0 on the right side, you also get minus 15. It works beautifully. What am I talking about? This equation over here. Let's try 15. I know it's difficult. Yes, if you want to skip checking, please skip the checking. We're not trying to torture you. What's 15 squared? 225. Plus 8 times 15. What's 8 times 15? What's going to be 80 and 40? It's 120. Minus 15. I'll write that down for you. Again, I'm checking 15. What do you get over there? 2 times 15 is 30, so you get 33. And let's see, 15 minus 5, that's 10, isn't it? Well, the right side's really easy. That's 330. Let's see, what's 225 plus 120? That's 345 minus 15. What's 345 minus 15 is 300 and, whoops, sorry about that. I'm doohickey there. It's going to be 330. Does it work? Of course it works. We write problems that work. It's really that simple. All right, let's look at number 10. Again, some people get tricked by this. We're not trying to trick anyone. And I really mean that. We're not trying to trick anyone. All right, look at it. What would I do first? It's not a 0, so I got to get a 0 in the problem. How am I going to do that? Well, I'll simplify. What do you get? X squared plus 2 minus 1 is plus x minus 2 equals 4. I would subtract 4 from both sides. And what would you get? You would get x squared plus x minus 6 equals 0. I have my 0. Now I'm going to use the product, 0 product rule. I got the 0. I can get the product now. Hopefully, anyway. 3 and 2. Let's see, plus 3 minus 2. Let's just check it. X times x is x squared. Plus 3 minus 2 is 1x, and you do get minus 6. What's the answer over here? X equals 2, or x equals minus 3. Let's check it. Where do we check it? In the original. Should be fairly easy to check. But again, you be the judge. If it's 2, what would I get? 1 times 4. That certainly equals 4. Let's try the minus 3. What would you get? Minus 4, just plugging it in, times minus 1. That also equals 4. They check out beautifully. All right, they really do. All right, let's take a look at number 11. It's a word problem. And I'm going to pull it on the side. All right, let me do that for you. And I'll take this guy here. And I'm going to pull this on the side somewhere. So, what does it say? It says the sum of a number and its square. Find the number. So it's a word problem. And what is it? X, whoops, I'll go back to black ink. X is the number. I do not know what the number is though. What does it say? The sum of a number and its square is 132. Well, this is good. I got the equation now. Now the question is, can I solve that equation? I can, but I need to rewrite it so I can take care of the 0 product rule in the problem. So what do you get over here? I'll write down for you. You get x squared plus x. Subtract 132 from both sides. You get this. And I realize some students are saying, "Oh, that 132 is too big for me." I hope not. I'm going to look at that and say, I don't know, maybe 11 times 12. Maybe it doesn't work. Who knows? I'm going to say, let's see, plus 12 minus 11. Let's see if it works. What's x times x? X squared. Then you get minus 11x plus 12x, which would be plus 1x. I hope you realize that 12 times minus 11 is going to be minus something. It's going to be 120 plus 12, which is 132. It works out pretty good. So what's the answer then? It's x equals minus 12 or x equals 11. What was our question now? Find the number. There's actually 2 numbers that fit this description. One of the numbers is 11. The other numbers is minus 12. These are the numbers. Again, you can check that out if you like with the original problem. What does it say? Let's just check out the 11 first. I would say the sum of a number and its square. What's the square of 11? 121. If you add that together, you would get 132. That worked out beautifully. Let's try this one. What does it say? The sum of a number and its square. What's square, minus 12? 144. That's also equal to 132. All right. So these are working out nicely. That certainly matches our key too, which is good. The key should be accurate. And again, if something you don't feel is accurate, you should bring it to our attention. All right. Let's do this one over here. And this could be tougher. Well, one thing I want to read, it says, the base of a triangle. I understand what the triangle looks like, but maybe not accurately what it looks like. But I know they're talking about a base of a triangle. So I'm going to, draw a base of a triangle down here. This is the base. Now, students often argue, do I really need to be able to understand what I've read? And I can't say this more than it really, you have to understand what you've read. Because it says the base of the triangle is 3 less than twice the triangle's height. Well, I gotta put a triangle down with a height now. So I'm gonna put this over here. This is its height. Some people call that the altitude. I put my triangle in. And by the way, I'm not claiming it's their triangle. I'm just saying, I think I understand this. All right. Let me read it again to you. The base of the triangle, this is the base. I'm going to use the letter B for that. Is 3 less than twice the triangle's height. It's kind of abstract, isn't it? So if someone said, what's the height of that triangle? I'd say it's H. H is the height or altitude. If someone said, what's the base of the triangle? I would say 2H minus 3. This is a visualization. Right now, that's a statement. There's not much I can do about that. Here's the deal, though. The very next sentence says the area. Let me remind you, area of a triangle. The grade school formula is 1/2 times the base times the height. Let's write this down. What's the area? 45. 1/2. What's the base? It's 2H minus 3. What's the height? It's H. All right. I think I'm ready to start, at least moving forward. I don't even know what the question is at this point, but I want to see if I can do it. I would say multiply both sides by the LCD. And what is that? 2. Let's do it and see what you get. On the left side, you get 90. On the right side, I would associate the 1/2 and the 2, and I get 1. Well, it would be 1 times 2H minus 3 times H. And here it's clear as day. This really has something to do with what we've been talking about, which is the zero product rule. Let's keep going. Might be tough. Let's try. 2H squared minus 3H. I'm going to subtract 90 from both sides. Again, I don't even know what the question is at this point. I'm not even concerned about the question. I'm concerned about solving an equation. I realize for some students, I actually believe they can't do this. You really have to stop thinking that way and say, I can do that. All right, this is going to be tough. And why is that? I don't have any choice for 2H squared, by the way, but I got lots of choices for the 90. And I just want to just go through it with you a little tiny bit at a time, right? So I'm going to say maybe it's 90 and 1. All right. Maybe it's 2 and 45. Maybe it's 3 and 30. I think you're getting the idea that, it could be some things. Keep going here. I'm wondering, I don't think it's any of those yet, but who knows? Maybe it is. Maybe I'm just giving up too quick. I'm going to take a look at them. I don't think I'd go to 4, but I think I might go to 5, right? And 5 times what? Let's see. You get 10, you get 50, and there's 40 left over. 18, right? Let me just make sure you understand what I did over there. 5 times 18 is 50 and 40 is 90. All right. Now, again, I'm not saying that's right, but I guess I could try that, right? But I think I should go a little bit further than that. Let me try 6. And 6 times what? 15, right? Let's see if that works. You get 60 and 30. Well, that's 90. Now, I got to be honest with you, though. The number of choices here, it's a lot of choices. And for a lot of students, that's just too much work. But you can keep on going. But I'm wondering if 15 and 6 might be more compatible. And I don't know. I'm going to try it. And I think I might see it now. I'm not saying it's right. I'm just thinking maybe this gives me a combination where I get the 3H in the middle. So I'll put this over here. And I don't know. This is my first try. Let's see if it goes. What's 2H times H? 2H squared. Plus 12H minus 15. Well, 12 minus 15 is minus 3. That worked beautifully. And what's minus 15 times 6? Well, it's going to be minus 90. All right, let's write this down now. And I'm not even thinking anymore. I'm doing an equation. 2H minus 15 equals 0, or H plus 6 is equal to 0. 2H equals 15. H equals 15 over 2. Well, the other one is H equals minus 6. Now, I realize the tendency of some students, they just want to box it and walk away. Please understand the question before you box it and walk away. What do they want to know? Find the base and the height. Okay, I got to be honest with you. And this is really something you got to pay attention to. There's no way the height could be minus 6. There's no way. Height could be 15 over 2, though. Now, someone says 15 over 2 what? I don't know. Got to go back and read. Inches. What's the base? Well, it's twice the height minus 3. 15 minus 3 is 12. 12 what? 12 inches. So write this down. The base, I believe, is 12 inches. We'll look at the key later. And I believe the height is 15 over 2. What would that be? 7.5 inches. Let's look at our key, see how we did. And someone says, do you really need to look at the key? We want you to look at the key. We don't want you to walk around and wonder if you're right. All right, what does it say? Base is 12 inches. I got that. Height is 7.5 inches. I have that as well. All right, so I think we complete the problem set. And what comes up next, it's the part where we're really trying to convince you guys that you need to work. Without working, you're going to find out that your schooling is really not going to have any substantial payoff. There's plenty of college graduates that come out of their university education, can't find a job. I was actually reading an article in the New York Times the other day about the number of doctors in the United States and that cannot find employment. And part of the reason for that is where they went to medical school, by the way. They may not have gone to a very good school. That's a big problem, by the way. Even though they passed their board exams, no one is willing to take them on. And that happens, all right? So I want to point out that the quality of your education is going to determine where you end up. Now, someone says, how do you get a quality education? It's not something that's given to you. It's something that you give to yourself, by the way. It's something that's earned, all right? So I want to get over here and talk about this. You got to get busy with this. What do I mean by this? You got to put a lot of work in, homework problems, all right? So it's important you're doing these problems over here. Now, what kind of problems are they? Very similar to what we've done in class, but you got to do these things over here. You have to do every single one, all right? Does it take time? I'll be honest with you, it doesn't take much time. However, if you want to come back later in the week, I will be publishing this at the whiteboard, me working these problems at the whiteboard, if you want to torture yourself and watch that. If you think you're good with this, just do it on your own. There's answers in the notes, by the way. Okay, thank you.